As we know from the theory, a Posicast controller can be very helpful in systems with a low damping, for example pendulum systems like a lifting crane. My name is Stef Wintraak, and in this video I'm going to show you a simulation example of a Posicast controller acting on a model of a lifting crane. Well, we made that model here in Simscape Dynamics. This is my model and this is the visualization of my model over here. When we click on it, we see how it's built. We have a world frame over here. We have the rails, these rails, which are modeled over here. We have a rectangular joint because this should move in the horizontal position. We have a link. We have a revolute joint, and attached to that the cord and the ball, as can be seen over here. We also added some air friction to the ball, implemented over there, and some friction to the trolley, viscous friction damping and Coulomb friction. And we added some friction to the trolley, and that all is subtracted from the force which is acting over here. So the force which is delivered by the PD controller. And as I said, because we control it in a feedback loop, I've implemented the PD controller over here, which is not tuned properly, but in a way that we have a stable system. And to the input of my system, I add a step. So the step, this system has to make in the horizontal position. So it's a position controller, so we also have to measure the position of the trolley, and we feed back that position here to the input of the PD controller. We are going to measure two things. We're going to measure the position of the controller. There is a figure already over here, and we're going to measure the angle, the swinging angle of the ball, which is depicted over here. So I'm going to run the simulation, and please notice how this visualization of the ball, how it will really behave, and then we can also look to the graphs which have been generated over there. So here we go, start the simulation, and yeah, you see already what was happening over there. We see the ball moving and resonating, which is also shown in that figure over here. And when we look to the maximum values, we see, well, that this value is about 22-23 degrees, so it's really swinging a lot. And after the settling time of, yeah, let's say 2 to 2.5 seconds, it really keeps on resonating over there, what we would expect, of course. And now we are going to add the Posicast controller in front of that pendulum, so in front of my lifting crane, so in the feedback loop as depicted over here. We can do it by putting that manual switch in this position. So the Posicast controller, it's implemented in the general way. It's 1 plus d over 1 plus d times -1 plus e to the power minus the delay time over here. That was a general transfer function of a Posicast controller. When you don't know exactly how we came to this transfer function, please watch the video about the Posicast controller. So here we have it, and now let's do the simulation once again, and please watch the behavior of the ball, and of course then look to the not only to the position of the trolley, but especially to the angle of the ball, how it's resonating after the settling time of the trolley has been reached. So here we go. This is my simulation, and here we see the angle of the ball. It's still doing the simulation, but what we still can conclude at this point is already that the maximum oscillation of my ball is much smaller than in the situation where we didn't use a Posicast controller, as we of course expected. Here we see that the maximum degree of the ball is 5.5 degrees, which is of course much smaller than in the previous situation in which we didn't have a Posicast controller. Well, let's play the animation once again, and please watch the behavior of the ball. So here we go, and you see that the resonating behavior of the ball was much smaller than without the Posicast controller, as we expected, of course. And of course, yeah, we put a step to the input, which is for a position controller, yeah, not that obvious choice. So a better choice could be a second order set point as created over here. And when we do that, so putting the manual switch in this position, you see that the behavior of the ball is increased with respect to the situation in which we only had that step. So the maximum oscillation amplitude over here is, let's say, 3.8 degrees. So yeah, it's somewhat better than without the second order position when we had the step position, and of course it's at the cost of a somewhat larger settling time. So what we have seen in this case, again, that also this simulation shows that the Posicast controller really helps in getting a much better step response for systems with a low amount of damping, like this lifting crane. And as said earlier, the implementation of a Posicast controller, which we did over here, is quite easy and really straightforward. Well, thanks again for watching, and I'll see you next time.